Good evening, everyone. On the behalf of Department of Mathematics, Wilson College Autonomous Mumbai, I welcome you all into the today's session. Our today's guest is Dr. Dipak S. Jadhav sir. He is an associate professor at Department of Mathematics, Srimati CHM College, Ulhasnagar. He will deal with the topic of sequence and series today. Over to you, sir.
Thank you. Let me share my screen. Yeah, is it visible to all of you?
Yes, sir.
Yes,
Okay. Okay, so meanwhile, other students join. All of you, please try this question. So what does the question says? Let x1 greater than 0. For n belongs to n, define a sequence. Xn plus 1 is equal to xn plus 4. If limit of this thing is 1 by 24, then the value of x1 is equal to. This is a question from 2025 question paper. I hope I am audible to all of
Yes, sir.
you. Okay. So we want to find this limit. Limit x tends to limit n tends to infinity 1 upon x2 into x3 plus 1 upon x3 into x4 and so on. It's given already 1 by 24. We want to find the value of x1. So what is x2? x2 is x1 plus 4. What is x3?
x2 plus 4.
Okay, so that will be nothing but x1 plus 2 into 4.
8.
Yes, sir.
Yeah.
So, sir,
x4.
xn will be x1 plus n minus 1 times 4.
Okay, so good. N will be x1 plus n minus 1 times 4. Okay, good.
So the terms are in arithmetic progression.
Yeah, good. Terms of the sequence are in arithmetic progression. How will you use this information? Maybe forget about the value of the limit. Suppose you want to evaluate this limit. What you will do? 1 upon x2 into x3 plus 1 upon into x4. The next term will be x4 into x5 and so on till 1 upon n plus 1, xn plus 2. So we want to evaluate this limit.
So we can write 1 by x2 into x3 as 1 by x2 minus 1 by x3, and the rest of the terms can similarly be written as 1 by x3 minus 1 by x4 plus dot dot dot. So we can cancel some terms, and at
Okay,
last
so
we will be left with 1 by x2 minus 1 by xn plus 2.
okay, so you mean to say let us try writing this as 1 upon x2 minus 1 upon x3. So if you want to write it like this, so what you will get? You will get
Sir,
x2.
for that we have to multiply 4 in the numerator and denominator.
Yes, sir. The common difference is 4 here.
Yeah. So yeah, correct. Yeah. So let us observe 1 upon x2 into x3. If we want to write it like 1 upon x2 minus 1 upon x3, then if I simplify the right hand side, I'll end up getting x3 minus x2 upon x2 into x3. But do I know the value of x3 minus x2?
So
So
that is
yes,
4. 4.
that is the value is 4. But I want this 1 here. So I need to multiply by 1 by 4 here.
Yes,
Yeah.
sir.
So then it is equal. Yeah, correct. So why this is 4? Because the information given in the problem itself. 10 plus 1 equal to xn plus 4. So from here I can say xn plus 1 minus xn is 4. So difference between every two consecutive term is 4. So we can use this and we can simplify this limit. So what it will give me? Limit n tends to infinity. The first term will be 1 by 4 into 1 by x2 minus 1 by x3. Yeah. The next
Yes,
term will
sir.
be 1 by 4 into 1 by x3 minus 1 by x4 plus and so on. The last term will be 1 by 4 1 by xn plus 1 minus 1 by xn plus 2. Very good. So finally I can pull out 1 by 4 and what left inside is
So 1 by x2 minus 1 by xn plus
1 by x2 minus 1 by n plus 2. Yeah, that's what we get. Okay. So this is nothing but 1 by x2. And what is the limit of 1 by xn minus xn plus 2?
0.
0. Yes, very good. That you have to observe. Why? Because the sequence is increasing. Can I say sequence is increasing? And it goes to infinity.
so
So
1
1
by
by x
xn will
goes
tend
to
to
0.
0 as n tends to infinity.
Yeah. So this is 1 by 24. It's already given. So what do we got 1 upon x2 as? 1 by 6. So x2 is 6. We want x1. So what do we know? x2 is x1 plus 4. 1 is 2.
It-
Yeah. Is it okay?
Yes, sir. Option B is the right answer.
Yes, sir.
Option B. I hope all of you have followed this.
Yes, sir.
Sir, can I ask a question?
Yes.
Sir, you have just started this problem only because I am not aware of the timing of today's class. I think it would be conducting in 7 o'clock. That is why I am getting little bit late.
Yeah. I have just started with this problem. No other
Okay,
problem.
okay, sir. Please, yes, sir. Okay, thank you, sir. I'm following on guiding.
Yeah. Okay. We have just solved one problem. This is also the problem from the last year paper, that is 2025. We want to find the value of this limit is equal to. So how will you evaluate this limit? So this will be equal to limit n tends to infinity.
Sir,
Yeah.
sir, here n tends to infinity. Here n is tending to infinity. But if we uh, uh, can we write here n tends to infinity? Can we write 1 by n? Then n tends to 0. Then it will be more easy to solve, and then we can expand e of x, sin of x, and cos of x, where the least term will be dominating. So answer will be like that will be the easiest way to get the answer.
Okay. So you want to say let's replace n by 1 by n.
Yes, sir. Then n tends to 0.
Okay. So that may be one of the way. But n is a natural number, so means
So we can let 1 by 2n equal to x, so that x tends to 0 as n tends to infinity.
yeah. Where does this term goes? Where does this term goes? And where does this term goes as n tends to infinity?
So the first one is goes to infinity,
Yeah.
and
What
the
about second one?
second one is bounded.
Goes
It
to
tends
0.
to 0.
0, sir.
Second one goes to 0. Good. What about
Yes,
the
sir.
third one?
The other
Third
two,
one?
the other limit
1,
is
sir.
bounded actually. Sine function and cos function are
1, sir.
bounded. So 1.
Yeah, yeah. So this is
1.
bounded and this is also bounded. But where does they go?
2. 1.
So
It
to
goes
1.
to
Exact.
1.
It goes to 1.
This goes to 0 and this goes to 1. So
1.
their addition goes to 1.
Yes, sir.
So if I split the limit over this function and the remaining part, then there is no harm. So like I can pull out this 8 outside, and this is n e to the power 1 by 2n minus 1 into limit n tends to infinity, sine of 1 by 2n plus cos of 1 by 2n. This part will be 1. 0 plus 1, that's 1. So we just have to tackle this part then. This is 0, this is infinity and this is 0. So the 0 into infinity form. We already know how to evaluate such limit. Either you convert 0 by 0 form or you convert infinity by infinity form. So let's convert it into this form. This is I think 0 by 0 form. So what you will have? You differentiate.
Numerator and denominator.
Yeah.
Sir,
What is the derivative of
sir,
limit?
I am a question, sir. It is okay, sir. You have split the product into two separate terms, but it would be possible when the entire limit, provided the entire limit is exist, then we can break them to evaluate
Yes,
separately. Okay,
yes, yes,
and
absolutely.
here if it is provided that n into e to the power 1 by 2n minus 1, it is exist finitely, then we can split in these two terms. Here sine 1 by 2n plus mod, this is finite term, so breaking is this part. So how can I say this is equal to, I'm I'm telling just first line.
Yeah, I understood. You want to say that we can apply algebra of limits provided limit of each function exists.
Yes,
That's what you
yes,
want to
that
say.
is why just first line, but after that all are okay.
Okay, fine. So here overall the limit exists because they have asked the value of this limit. They haven't asked us
It is
fi-
subjected that exist is finitely.
overall limit exists. Overall means the
Hmm.
product limit exists.
Yeah,
And
sir.
yeah, and this bracket we can observe this also exists. Also exists.
Exist.
Yeah. Only the
So,
remaining part is this product. So we haven't splitted this product. We have kept it as it is. N into e raised to 1 by 2n minus 1. This product we don't know. It's 0 into infinity
yeah.
form. So we have kept as it is. We haven't broken that.
Okay. Okay, sir. Okay, I understand.
So overall exists and this exists. So that's why this product limit also exists.
Okay, okay, sir.
And then I hope it is easy to evaluate after this. You apply
Yes,
L'Hopital,
yes, yes. Yes, it is
then
redundant
you will
now.
get some answer. So that you complete. Okay. Okay. Let's move on to our discussion on infinite series.
Sir, I have a query.
Yes.
Sir, sir, in the second last line, instead of applying L'Hopital rule, so can we also apply here the formula limit x tends to 0 e to the power x minus 1 by x? If we write 1 by n as 1 by 2n, and we can, so we have 8 here, right? So if
This
we write
formula
it
you
as
want to
4
see.
into 2, and we can move the 2 in the denominator part, so we can use the formula.
Yeah. This is what you want to use. Huh?
Yes, sir.
Yeah. Oh yes, absolutely. You can use that also. No
Okay.
worries. Yeah.
Sir,
So
can
then,
you
so I
help
think,
me with this?
Yes. What?
Sir, can you please solve this?
Which this e raised to 1 by 2 and what is the derivative of the numerator? 1 by 2 into minus 1 by n square, and the derivative of the denominator is minus 1 by n square.
Yes, sir. Yes,
So
sir. I
what you will
got it.
get?
Yeah,
Yeah.
I got it.
This get cancelled and you have to apply directly limits. It is 4 into limit n tends to
Limit.
infinity. Yeah. That's 4.
Yes, sir. Yes, sir.
Good.
Thank you.
Infinite series. So I have asked you to revise the result. Also, I hope you must have revised the result. But so first thing is definition of convergence of infinite series. Convergence of infinite series. So when do we say a series is convergent? Normally it is denoted by n from 1 to infinity an. This is the sum of that infinite series. So we say that by definition it converges if its sequence of partial sum converges. I hope the sequence of partial sums is you all are aware about this.
Yes, sir.
If this Sn converges to L, then we say this infinite series converges and the sum of that infinite series is L. Then we have something called as necessary criteria, the most important result in the case of series. What is that? If summation an converges, then an goes to 0. Yeah,
Yes,
its
sir.
n term of the series goes to 0. So the important part of the statement is contrapositive. If an does not goes to 0, then that will imply summation an diverges.
Not
Yeah,
good.
is it okay?
That
Yes. Yes, correct. Yes, correct. And then we have geometric series test. One upon a plus ar square ar is to n. It goes on. Such a series is called as geometric series. Such a series is called as geometric series with the first term as a and the common ratio is r. So we know that this converges to a upon 1 minus r if absolute value of r is less than 1.
one.
Yes,
Yes,
very
sir.
good. Then we have not alternating series, telescopic series. Telescopic series, series of the type like this. So such kind of series can be broken the way we have written in the just now observed in this above example. We have written 1 upon x2 into x3 as a by using partial fraction. We have written as a 1 upon x2 minus 1 upon x3. So, same thing. This so 1 upon n into n plus 1 can be written like this: 1 upon n minus 1 upon n plus 1. And then you need to compute the sequence of partial term. That's a1 plus a2 plus and so on an. So you'll have this an for all n. What you will get? 1 minus 1 upon 2 plus 1 upon 2 minus 1 upon 3 upon n minus 1 upon n plus 1. Due to telescoping kind of nature, the in-between term all get cancelled and we survive only one first term and the last term. And then we observe Sn goes to 1. So by definition, its sequence of partial sum converges. So your series also converges. And it converges, the sum of the series is the limit of sequence of partial sum. Then we have something called as comparison test. We have mod of an less than or equal to mod of bn. And if summation mod bn converges, then we know that summation mod an also converges. The upper series on the upper side converges, then the series on the lower side also converges. This is the comparison test. And one more inference of this comparison test: if mod series on the lower side diverges, then series on the upper side also diverges. And we have something called as limit form of comparison test. We have two series, summation an and summation bn, and then we compute something called as L is equal to limit n tends to infinity mod of an by bn. So what do we know about this? Obviously, L is greater than equal to 0 because it's a limit of positive terms. So the first thing, if L is non-zero, then summation an and summation bn behaves alike. What do we mean by behaves alike? Either both will
diverges or converges together.
Either both will converge or both will diverge. And there is, if L is equal to 0, then what can you say?
It depends on the nature of, I think, the
No.
sequence.
No. At least you can conclude about one statement. If one of them is convergent, other also convergent. And if one of them is divergent, other also divergent.
If L is equal to 0, then we can say only one side, okay?
Yeah, we can say only one side. Yeah, that's what I wanted to say. This. So when you apply the definition for epsilon equal to 1, there exists n belongs to m, so that mod of an by bn minus 0 is less than 1 or all n greater than equal to n. So you will have mod an is less than mod bn. So if this converges, this also converges. And if this diverges, this also diverges. Series on upper side converges, then series on lower side convergent. So we have only one kind of conclusion value. This is about comparison and limit form of comparison test. Then we have some test for
sir, if L is equal to I think infinite.
in connection with this statement you're talking about.
Thus, L is not equal to 0, L is finite, L is 0, L is non-zero, and something L like infinite, unbounded. Then
Means you mean to say L is if this limit does not exist, if
yes,
it goes to infinity.
Yes.
In that case, the test fails. We cannot apply the comparison test. Limit form of comparison test. You have to choose Bn for a given series summation an. If you want to check whether it is convergent or divergent, you have to choose the series summation Bn in such a way that this limit either exists or it is zero.
Yeah.
Most 99% of the time we choose Bn in such a way that this limit exists and non-zero. So both series will behave alike.
And okay, sir. And
So what is the ratio test?
So an plus 1 over an mod of.
Mod of an plus 1 over an. If it is equal to L, if there are three conditions. The first condition, L is less than 1,
then the series converges.
converges.
And if L is
L
greater
is
than
greater than
1,
1,
then the series diverges.
diverges.
And
And
if
third,
L is equal to 1, then
then
the
test
series may
fails.
or may not converge. Yes.
Yeah, so that means the test fails. Root test for series summation an, L is limit n tends to infinity of mod an raised to 1 by n. And again the same three conclusion. If L is less than 1, series converges. If L is greater than 1, series diverges. And if L is equal to 1, test fails.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, very good. Then we have alternating series.
Hello, sir.
Yes.
So when do we get to know that when a test of some series is failed, then when do we get to know that which test we use so that the required result we will get?
There are only plenty of tests available to check whether series is convergent or divergent. When we solve several problems, then we have some instinct for a given infinite series, which kind of test will work. Most of the time, ratio test, root test works. But sometimes it's easy to use comparison test, maybe limit form of comparison test, and so on. In rare cases, if like we want to find sum of an infinite series, then we just have only two tests in our hand. One is geometric series test, another is telescoping series. If that series is of the type some telescoping kind of series, then we can find actual sum of that series. And if that series is of the type geometric series, then we can find actual sum of the series. Or yeah, possibly we can compute the sequence of partial sum and its limit. Then only we can compute the sum of that infinite series. Only in these three cases we can actually compute sum of an infinite series, but in the rest of the cases we can only talk about, or we can say that whether series is convergent or divergent. But which test is applicable to which series, that thing you have to learn by practicing more and more problems on infinite series. Yeah, is it okay?
Okay, sir. Thank you, sir.
Yeah, alternating series somewhat looks like this, where n is greater than 0. Then the such a alternating series converges provided what are the conditions? An greater than 0. Second, an is decreasing.
And limit n tends to infinity for n equals 0.
Yeah, an goes to 0. Then summation minus 1 raised to is convergent. Yeah, good. Apart from this, we have also learned something called as power series. Series of the type x minus x naught. This kind of series is called as power series. and from 0 to infinity. This is a power series about x is equal to x.
X0.
Yeah. So such a power series always converges at one point, and that one point is nothing but its center. Okay. At x equal to x0, it always converges. Apart from this, it may converge on an interval of the type x0 minus some capital R, comma x0 plus some capital R. If this is a maximum possible interval on which the series converges, then we say R is radius of convergence of that power series. And for given power series, the obvious question is to find its radius of convergence or to find its interval of convergence. Possibly, interval of convergence may be one of these.
There are 4 cases.
Yeah, these are those 4 cases. Yeah, this is first, second, third, and fourth. It depends on boundary points, whether they are included or excluded. Depending on that, we have interval of convergence for the given power. Is it okay?
Yes, sir.
Okay, let's move on to solving some problems. I hope the problem is visible to all of you.
Yes, sir.
Yes, sir.
Yes, sir.
Try this problem. So whenever you see such kind of sum, so the denominator n square minus 4n plus 3, is it possible to factorize the denominator?
Yes, sir. N minus 1 into n minus 3.
N minus 3 into n minus 1. So try applying the partial fraction. I want to write it as a upon n minus 1 plus b upon n minus 3. I hope all of you know how to do partial fraction.
Yes, sir.
Simply you try computing n 1 upon n minus 1 minus 1 upon n minus 3. So what you will get answer? N minus 3 minus n plus 1. So you will have minus 2. So anybody got the partial fraction? Three times 1 upon n minus 3 minus 1 upon n minus 1. Yeah.
Yes, sir.
Very good. And then we try computing this is an. So this is also an. So try computing Sn. What is Sn? A1 plus sequence of partial sums. A1 is what? 3 into. So we pull out 3 common from all the terms. A1 is
1 minus 1 by 3.
yeah. Sorry, we want from A4 onwards. Yeah. Summation n runs from 4 to infinity. First will be 4, 5, and so on. So A4 will be 1 upon 4 minus 3, that's 1 upon 4 minus 1, plus A5 will be 1 upon 5 minus 3 upon 5 minus 1. The next term will be 1 upon 6 minus 3 minus 1 upon 6 minus 1, n minus 3 upon n minus 1. So what goes and what survives? First is 1 minus 1 upon 3 plus 1 upon 2 minus 1 upon 4, 1 upon 3 minus 1 upon 5. So which terms are getting cancelled and which terms are getting survived? I think minus 1 by 3 plus 1 by 3 get cancelled. So what survives? This
1 plus 1 by 2.
this survives. Yeah. 1 plus 1 by 2. And what about at the end? So you can check minus 1 upon n minus 2 minus 1 upon n minus 1. Yeah. So where does Sn goes?
9 by 2.
9 by. So the series converges to 9 by 2. Yeah, is it okay? All of you check the answer carefully.
Sir, how did we get at the last it tends to 9 by 2 by putting as by finding the limit substituting n equal to infinity by finding limit n tends to infinity at the end?
Means 3 into 1 plus half is 3 by 2. So 3 into 3 by 2 is 9 by 2.
9 by 2. Okay, fine.
Sir, can you explain how 1 minus 1 by n minus 2 and minus 1 by n minus 1 is remaining?
Yeah. So meanwhile, I explained this. Those who have finished can try the second problem. See, in this above sum, these are the first two terms.
Yes, sir.
This is the first term and this is the second term.
Yes, sir.
So what is the previous term to this? This is an. What is an minus 1? Let us write an minus 2, an minus 1, and an. What is an minus 2?
1 by n minus 5 minus 1 by n minus 3.
Yeah, 1 by n minus 5 minus 1 by n minus 3. Yeah.
Yes, sir.
Plus an minus 1 will be 1 by n
1 by n
minus
minus 4
4. Good.
minus 1 by
N minus 2. Yeah. And an will be 1 upon n minus 3 minus 1 upon n minus 1. So observe what are getting cancelled. N minus 3 get cancelled. Yeah.
Yes, sir.
N minus 4 will get cancelled previous to that.
Yes,
So
sir.
write an minus 3. So that will get cancelled. So from last two terms, only term survivals are
Minus 1 by n minus 2 minus 1 by n minus 1. Yes,
that's
sir.
what these two terms. Good. This is also the similar kind of problem. You have to apply the partial fraction. So what is an here?
So are we supposed to use alternating series test over here?
We actually don't want to conclude whether it is convergent or divergent. We actually want its sum.
Value. Okay. Yes, sir.
Yeah. Alternating series, Leibniz test tells you only about whether it is convergent or divergent.
Yes, sir. Yes.
So what this will be? N plus 2 into n minus 1. Yeah.
Yes, sir.
So apply the partial fraction. What you will get? Is it 1 upon n minus 1 minus 1 upon n plus 2? Is this what you will get?
Then we
Try
need to
simplifying.
multiply 1 by 3.
1 by 3. N plus 2 minus n. Yeah. So you'll have 3 upon this. So you need to multiply by to
1
balance
by
the
3.
factor. Yeah. So 1 by 3 times this. Good. Is that okay for all of you?
Yes,
But you
sir.
also have minus 1 raised to n here. So let's multiply by that. So an will be minus 1 raised to n upon n square plus n minus 2. So that is nothing but 1 by 3 times minus 1 raised to n upon n minus 1 minus 1 raised to n upon n plus 2. Is it okay?
Yes, sir.
Yes.
Yeah. So since we want this n runs from 2 to infinity. So summation n runs from 2 to infinity. An is 1 by 3 minus 1 raised to n upon n minus 1 minus. So can you tell me, means can I split this infinite sum over this subtraction? Or in other words, can I write it like this? I can pull out. Is it possible to write it like this?
Yes, sir.
Which results we are applying here? Are we applying algebra of convergent series? If two series summation an and summation bn converges, then summation an minus bn also converges.
Yes, sir.
Yeah.
Yes.
Yeah. So now the question is it possible to find this infinite sum? Is it possible to find this infinite sum? Because our question says we do not want to just check whether it is convergent or divergent. We want to find its sum. So that means this infinite sum exists, and we have some answer to this. And this also exists, and we have some answer to this.
Can I
So the
solve
first series is
even and
somewhat of
odd?
the Maclaurin series type.
Yeah. Yes. You need to use Maclaurin series. For which function you like to use the Maclaurin series?
For the first series,
Yeah. But which function? Maclaurin
Both
series
1
we normally
plus x.
1 plus
ln 1 plus x,
ln 1 plus
where
x. So anybody knows the series for 1 plus x? Ln 1 plus x?
Sir, 1 plus x minus 1 plus x square by 2 plus 1 plus x the whole cube by 3.
No. Let's see what is the series for this and when it is valid. Okay. So instead of actually computing Maclaurin series for this function, what we will do is we'll like to observe this 1 upon 1 minus x. We already know the series expansion for this.
Yes, sir.
What is that?
1 plus x plus x squared plus so
And we
on.
know this is valid for mod x less than 1.
1.
Yeah. So I have some alternating kind of terms. I need to have alternating kind of term here also. So you replace x by minus x in this. So what you will have 1 upon 1 plus x will be 1 minus x plus
X square
x cube
minus x cube
minus
X
x cube
cube
plus
plus
x raised to
etc.
4
x raised to 4.
Plus etc.
mod x less than 1. And now I know how to get ln of 1 minus x from this function. Yeah. The standard connection is integrate term by term.
1 by integrate both sides.
Integrate term by term. So what you will have? Integration of 1 upon 1 plus x dx integrating 1 minus x plus x square minus x plus x is to 4 dx. Left hand side is ln of 1 plus x. Absolutely correct. What about right hand side?
X minus x
X
square by
X
2
minus
plus
x
x cube by
square by
3.
2 plus x cube by 3 minus x raised to power 4 by 4.
Yeah. So when you say such a thing, you are applying very strong result. We know that integral of finite sum is finite sum of integral. That is integral of f plus g. Is integral of f plus integral of g. But if we have something like infinite sum, then it's not obvious that integral of infinite sum is equal to infinite sum of integral. Okay. That function should satisfy some conditions, then only this result exists. But in case of power series, all those prerequisite are already satisfied by the functions, and you can integrate term by term. Similarly, you can differentiate term by term. So here, the answer that you said is absolutely correct. It is x
X
minus x
minus
square
x
by
square by 2 plus x cubed by 3 minus x raised to 4 by 4 plus x raised to 5 by 5 plus etc.
yeah, yeah, good.
Sir,
So from this, yes,
sir, what are the conditions for infinite integral?
conditions that you need to learn something called as sequence and series of functions. And then you have three standard theorems: term by term differentiation, term by term integration, and term by term limit. Summation fnx. Have you ever came across series of functions or sequence of functions?
Yes, sir.
Good. So there we study all these three standard theorem. You can refer that topic. All fn's needs to be R integrable on the given domain, and fn should converge uniformly on the given domain. These are the two hypothesis conditions required to conclude that this also converges, this also remain integrable, and this is equal to summation fnx. Yeah. Sorry.
Okay.
So, okay. So what are the two conditions? The sequence of functions should converge uniformly on the given domain, and each fn is Riemann integrable. Then integral of infinite sum is infinite sum of integral. And here fn is nothing but simple polynomials. Polynomials we already know are very nice behaving functions. They are uniformly continuous on any closed and bounded domain, and they are integrable too. So both the hypotheses are satisfied. So term by term integration is valid. So from here, how will I get this? Is it possible to get this? Finally, what I want? Summation minus 1
We
raised
have
to
to integrate within the limit 0, 1.
yeah, yeah. So this integration is valid for mod x less than 1. Yeah. 0 less than x less than 1. Yeah. Absolutely correct. and we also want this. So let us try expanding this. What is the expansion of this? क्या आएगा ये when you expand n from 2 to infinity minus 1 raised to n upon n minus 1. You'll have 1 upon 1 minus 1 upon 2 plus 1 upon 3 minus 1 upon 4. This is what you will get. Minus 1 upon 6. In this, when you expand this infinite sum, you'll get something like this. Something like this. So in this expansion, put x equal to 1. So what you will get? ln of 2 on the left hand side, on the
is
right hand
equal
side.
to 1 minus
Expansion of
1 by
ln 2.
2.
1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5.
Yeah. So can I say this is equal to ln of 2?
Yes, sir.
Yeah.
Yes, sir.
Okay. So one question I wanted to ask is that we are saying that this expansion is valid for mod x less than 1. But still we are substituting x is equal to 1 here. Is there any reason for this? Observe.
If you are thinking, I am getting a question, and it is a valid question because it is in open 01, it is converted following this
Yeah. So you can,
assumption.
the equality valid for any value of x between 0 and 1. But here we are using it for x equal to 1.
Yes, yes.
Same way, we want this n from 2 to infinity minus 1 raised to n upon n plus 2. So summation n from 2 to infinity minus 1 raised to n upon n plus 2. So that will be nothing but, let us expand. 1 upon 2 plus 2, that is 4. Minus 1 upon 5 plus 1 upon 6. So how much is this? Minus 1 upon 7. If I use the same trick here, x equal to 1. So how much is this?
Sir, can we say it is ln minus 1 plus 1 by 2 minus 1 by 3 plus 1 by 4?
Yeah, exactly. That's what we have to say. So this will be equal to how much?
But sir, why did we use x equal to 1?
Yeah. You think on that.
Okay.
Think on that. So this will be, I think, 5 by 6 minus ln of 2. You have to add these three terms. 1 minus 1 by 2 plus 1 by 3. That's 5 by 6. And the yeah.
Yes.
But
Yes, sir.
sir, in the
Yes.
above thing, we are getting it as ln 2. The expansion is 1 minus 1 by 2 plus 1 by 3 minus 1 by 4.
Yes.
But here we are getting it as, for the second summation, we are getting it as 1 by 4 is positive, 1 by 5 is negative. So, won't the sum will be different?
Yes, sir. Yes, sir.
Okay, let's see. This equality you followed, ln of 2 equal to this. There is no doubt
Yes,
in this.
yes. Yes, it's clear.
Okay. So from here, transfer this part on the right hand side and transfer this part on the left. So what you will get? 1 minus 1 by 2 plus 1 by 3 minus ln of 2 equal to 1 by 4 minus 1 by 5 plus 1 by 6. That's what you will get.
Okay, sir. Okay, sir. Clear. Thank you, sir.
Okay, good. So that's why I have wrote this equal to this. So then finally, what is the answer? This first we got ln of 2 and the second we got 5 by 6 minus ln of 2. So if I substitute here, what I'm going to get? It's ln of 2 minus 5 by 6 minus ln of 2. So that's 1 by 3 into 2
by
ln of
3
2
log 2.
minus 5 by 6. This is what we will get. So what is the answer then?
So we need to
I hope you
multiply
can.
by
Sir,
1 by 3 to
can we
match
write
with
it
the
as
option.
1 by 3 instead of 2 ln 2? Can we write it as ln 4?
Yeah, you can, but you have to match up with one of the option, no?
Okay, okay.
Option
So I hope
C.
now you can guess the correct
Option
option. Yeah.
C.
Sir,
Yes.
it's option C.
Yeah. Now, anybody can tell me the answer why means why there is no harm in substituting x equal to 1 in this expansion?
Sir, is it because of the Leibniz test?
Yeah, you are almost correct, but yeah. So there is something we have discussed about, something called as radius of convergence of a power series and interval of convergence of a power series. Yeah. What is the difference between interval of convergence? Interval of convergence, you have to think of the two endpoints separately. Either left endpoint may be included, right endpoint excluded, or right endpoint excluded, left endpoint included, or both endpoints excluded or both included. That depends on the nature of the series or the given power series. Yeah, you know that. So
Yes, sir.
how do you check whether left point is included or not? So that we check by actually substituting x by these four specific values. Sorry, two specific values. One is the left hand point, one is a right hand point. So same thing is happening here. This is a expression on the right hand side. What is that expression? X minus x square by 2 plus x cube by 3 minus x to 4 by 4 plus x to 5 by 5. And we have this equal to ln of 1 plus x for mod x less than 1, for 0x less than 1. So, sorry, minus 1 less than x less than 1, mod x less than 1. Okay. So if I substitute x equal to 1 here, what I'm going to end up getting? 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 and so on. And we know this is convergent series. Yeah. Converges by Leibniz test.
Alternative.
Leibniz test for alternating series. Okay.
Yes.
And what this expression will give me for x equal to minus 1?
Minus 1 plus 1 by 2. Minus 1 by
Minus
3.
1 minus 1 by 2 minus 1
Yes.
by 3 minus 1 by
Yes.
4.
Yes,
This
all
is
the
what it
terms
will get.
negative.
Yeah. So this is nothing but minus, if I pull out summation 1 by n harmonic series. This is a kind of harmonic series.
Yes, sir.
And what do we know about this series? Diverges, I hope.
Yes,
By
summation 1
test.
prime it diverges.
Diverges. So interval of convergence for this expression will be what?
Infinity.
Open
Either
interval
minus 1
minus
or 2.
1 to
Open at
close
minus 1
interval.
and closed at
1.
1.
1.
Yeah. Is it okay? Is it
Yes,
okay?
sir.
Yes, sir.
So that's why there is no harm in substituting x equal to 1. There is no harm in substituting x equal to 1. I hope you all must have followed this now.
Yes, sir.
Yes, very clearly
Yes, sir.
following the.
Clear now.
Yes, there are no headache of remembering the series expansion of log x. It is from basic to understandability.
Yeah. Yeah, this problem quickly. Now here we don't want to find any limit of that infinite series, but we would like to guess which one is convergent and which one is divergent. So summation an.
Summation an.
an plus 2 into 3n plus 4. This series, is it convergent or divergent?
Convergent, sir.
Yeah. What is the argument for convergent?
Telescope.
By comparing with 1 by n square.
Yes, absolutely correct. See, what is an here? 1 upon 3n plus 2 into 3n plus 4. Yeah. What is the relation between this and this? 3n into 3n. The relation between these two terms for all n?
Less than
Less
equal
than equal.
to.
Less
This
than
is
equal.
less
First one is less than equal
so
to
it's less
the
than or
second
equal
one.
to 1 by 9n square.
Yes, correct. So I hope all of you know that if we decrease the denominator, overall value increases. Yeah.
Yes, sir.
And
Yes,
if
sir.
we increase the denominator, then value
Overall value decreases.
decreases. So you keep this one mantra in your back of mind. So here we have decreased the denominator. We have decreased mine. We have excluded this plus 2 and plus 4. So we have decreased the denominator. So value will increase. And this series, I hope, converges because it is nothing but summation 1 by n square. Yeah, this converges by P series test. By comparison test, summation n also converges. Is that okay?
Yes, sir.
Okay,
Yes,
so
sir.
this option is ruled out and this option is ruled out. What about Bn? Bn is what? N cube plus cos of 3 raised to n upon 3 raised to n plus n cube. Which test you will like to use to conclude whether it is convergent or divergent?
Root test.
Root test, but then how will you compute cos? Means how will you
First,
compute
we
the
can
Sir,
compute
maybe
the
ratio test
absolute
will be good.
convergence of the series. Then we can apply the ratio test.
ratio test?
Yes, ratio test will maybe work.
Okay, so you can try by ratio. Try by ratio
Sir,
test.
by comparison
Comparison
test.
test will be quite on the easier side to do.
Comparison test or maybe limit form of comparison test.
Yes, sir.
So what
Yes,
Cn
sir.
you will choose? N cube from the numerator and 3 raised to n from the denominator.
Yes, sir.
So what you will get? Limit n tends to infinity of Bn upon Cn.
It's divergent.
Bn upon Cn. What is Bn? Cube plus cos 3
And
raised to n upon 3 raised to n plus n cube. Then you 3 raised to n upon n cube.
Sir, how did we choose this particular Cn?
It's just a trial and error.
Okay, sir.
What else you will like to choose?
Right, sir.
There is a possibility that I may choose this, but that will give me 1. Yeah.
Yes, sir.
Yes, sir.
Yeah. So what is this limit? Does this limit exist? So you divide by n cube, what you will get 1 plus cos 3 raised to n upon n cube, and you divide by here by this part by 3 raised to n. So what you will get? 1 plus
1 plus n cube by 3 to the power n.
So what is the value of the limit? This, where does this term goes? Cos 3 raised to n upon n cube. This goes to 0
Sir,
straight
over
forward.
Yes, sir.
So this is 1 plus 0. And what about the other bracket?
It
Oh.
also goes to 1.
1 plus, where does this n cube upon 3 raised to n goes?
Infinity.
Infinity.
So
1 by infinity is 0.
N cube upon 3 raised to n goes to 0. Yeah?
Yes, sir.
Infinity.
So can I say these two series will behave alike?
Yes,
Yes,
sir.
sir. By direct
yes, sir.
comparison test.
And now for Cn, you can actually apply a ratio test. What is a ratio test then? Cn plus 1 by Cn. So that is nothing but n plus 1 whole cube upon 3 raised to n plus 1 and 3 raised to n upon n cube. So take out what this will gives you.
Sir, is it 1 by
This is
3
1
Cn
plus
plus
1
1
by
by
n.
Cn?
1 by 3. Yeah. So this is 1 by 3. Limit, it goes to 1 by 3. Which
Yes,
is
sir.
less than 1. So what I can conclude about summation Cn?
It is
It's
convergent.
convergent.
Convergent. Yes, absolutely correct. So by ratio test, I can say summation Cn is convergent. So summation Bn is also convergent. So
Convergent.
what is my correct option?
Option D.
Yeah, good. Both
Both
summation
An
N and
and
summation Bn
Bn
are,
convergent.
yes, correct. Okay. So we will stop for today. We will continue discussing infinite series problem in the next lecture. Is that okay?
Yes, sir.
Yes.
Okay, sir. Thank you for answers.
Participants, if you have any further queries, then now you may ask to the sir directly, one by one.
Hello, sir.
Yes, please.
Sir, if there is finite terms in the series and it is asked to find the radius of convergence, then it will be convergent everywhere, right?
Yes, yes. Means it's not a series in that case. It's a finite sum.
Yes, sir.
Yeah, you mean
Sir,
to
but
say
in
the rest of the terms are 0.
yes, sir. The coefficient are 0.
Yeah. So radius of convergence is full R.
Every,
Converges for
every
every x in R. Yeah.
yes, sir. Sir, in the question it was given that find the radius of convergence, and there was only 4 terms.
Okay. So infinity in that case radius of convergence.
Okay, sir. Thank you, sir.
Yes.
Sir, actually, I am a bit new to the concept of radius of conversion. So can you please explain it a little?
Power series, I hope you understood.
Yes, sir.
Here it is.
Sir.
Expression of this type is called power series. So if I expand this, what I'm going to get? A naught x minus x naught raised to 0 plus a1 x minus x naught raised to 1 plus a2 x minus x naught raised to 2 and so on.
Yes, sir.
So in this, if I put x equal to x0, what I'm going to get? A naught plus 0 plus 0 plus 0.
Right, sir. Yes.
So that's nothing but a naught. That's nothing but a naught.
Yes, sir.
So what does that mean? That means that your power series always converges at a center point at x equal to x naught. Okay.
Okay.
Every power series always converges at x equal to x naught. Okay.
Okay, sir.
So on the real line, you have one point x naught at which your power series always converges. And then we get one result which says that if your power series converges at some point x1 away from x naught, then you get an interval on which it converges. This is a result in the theory of power series, which says that if power series converges at x equal to x naught, then you get an interval on which your power series converges around x naught.
Right, sir.
Okay. And then what we do is we try to expand this interval further and further. One step will come when your power series, you will get a largest interval on which your power series converges, and outside it diverges. Outside it diverges. This is the largest possible interval on which your power series converges, and outside it diverges. So a radius of this largest possible interval is called as radius of convergence.
Okay, sir.
Radius of convergence. And once you have this largest possible interval, then only 2 points are left out. Which are those 2 points? End points of this largest interval.
Got it,
These
sir.
these two endpoints we directly substitute in the given power series, and we check by applying several tests that we have already studied. Because when you replace x by some x1 in the given power series expression, it becomes a infinite series of real numbers, which we can check whether it is convergent or divergent. And accordingly, you have one of the four intervals as interval of convergence. Is that okay?
Understood, sir.
Okay, fine. So possibly this radius of convergence may be 0, or it may be some finite real number, or it may be infinity also. It may be infinity also. All three values are allowed.
So, sir,
If
there
it is 0,
can
that
exist a
means
sequence. There
which
can exist a
sequence?
series where it is convergent in whole real line.
Yes.
Okay, sir.
For example, let's take this 1 plus x upon 1 factorial plus x cube upon 2 factorial plus x cube upon 3 factorial.
E raised to x.
This series, this is e raised to x. The radius of convergence of this power series is infinity. It converges for every x.
Okay, sir.
In fact, series for sin x and cos x, those are also convergent for every real number.
Okay, sir.
Yeah.
Got it, sir. Thank you, sir.
Okay. Yeah.
Sir,
Yes.
sir, the geometrical meaning of radius of convergence will be on real line or in R2?
For infinite series of real numbers, it is in set of real numbers. If you change the domain of your infinite series, maybe complex number, then it is in Argand plane. That is, you can say somewhat in R2. Then you will have a disk instead of interval, you will have open disk in which your series converges, and outside of that open disk, series diverges. So radius of that open disk is a radius of convergence of that power series. Is that okay?
Okay, sir. Thank you, sir.
Yeah.
I hope there are no more queries left. Thank you so much for such an engaging and wonderful session, Deepak sir. Really, it was very nice. Participants, please note that next session will be on Tuesday, 26 August 2025 from 6 p.m. to 7 p.m. as per the schedule. So let us meet there. Goodbye.
Thank you so much, sir.
Thank you so much, sir.
Thank you, all of you.
No.